So right here, this is going to be the DEX that we're going to build. You can see here, we can swap out our Matic because I'm using this on Mumbai here. So native token is going to be Matic, and we can swap it out for a token called the DEX T or DEX token. So in here, we can say, I'm going to put 0.1 Matic. You can see here in return, I'm going to get 0.86, all of this DEX tokens here. We can hit swap. We get a transaction that comes up to go ahead and go through with our swap. You can see we're going to be swapping 0.1 Matic. So we'll put the swap through. You can see here that it is swapping out our token. Once that goes through, you can see swap was executed successfully. If we look here, I go down to 0.680. It's a little small here, but you can see my DEX, my balance for my token also went up to 1.7 of the DEX T. Now you can see if I do 0.1 again, the calculation is I'm going to get a little bit less tokens back here. And we're going to be creating our own DEX contract. You can swap it around here this way too. So if I swap it around and put in, I want to swap back my token to Matic, you can see this is what we're going to get calculated in return. Hey everyone, Sean Watasa here, back with another tutorial video. And in today's tutorial video, we're going to be building a very simple DEX. So we're going to build a very simple swap where a user can swap a specified token for a native token or vice versa. An overview of what we're going to be covering in this video: we'll first create our DEX contract. We'll also deploy our ERC20 token contract that we're going to use with our DEX. We'll then jump in and build out our very own DEX application. So with all of that being said, let's jump on our computer here and let's get started. Once on thirdweb's dashboard and I have my wallet connected, I'm going to head over to the contracts tab and I'm going to deploy a new contract. And here I'm going to deploy a token contract, which is an ERC20 contract. So I'm going to select that. I'm going to hit deploy now. I'm going to name this Sean token. And my symbol is going to be Sean. You can add a description, you can add an image. And I'm going to come down here to the network and chain, select the dropdown. And from that dropdown, you can select any EVM compatible blockchain or network. We support all of them here. So we can search them by chain name. You can search it by chain ID. I'm going to be using Mumbai for this tutorial here. So I'm going to select Mumbai and then I'm going to select deploy now. We'll get a transaction that appears here. So I'm just going to confirm that transaction to deploy my contract. Then we'll get another signature request here. This is to add it to our thirdweb dashboard. So I'm going to just sign that. And again, what we're deploying here, this is just a token that we're going to use within our decentralized exchange. This is going to be the token that we're going to be able to swap back and forth for our native token, depending on the chain that we deploy it to. In our case, or in my case, it's going to be Matic since I deployed it to the Mumbai testnet. So once our token contract deploys, you'll be brought to the contract dashboard. On the left-hand side here, we're going to navigate down to the tokens tab. And right here, we have 0 tokens. So we're going to mint some tokens and supply here. And I'm just going to mint 1 million tokens. So we're going to hit mint here. And I am going to confirm. Once that's done, you can see here our total supply is now 1 million tokens. The 1 million tokens is owned by this wallet, which I use to deploy this contract. So we're going to need this here in order to provide it to our DEX contract so that our contract knows what tokens it can swap through. So once that is done, we have our token that we want to swap. Let's now create our DEX contract. So I'm going to open up my terminal here and I'm going to run npx thirdweb create contract. And we're going to create our very own DEX contract using thirdweb here. So we're going to name our project. I'm just going to name this DEX contract. And I'm going to use hard hat for this. You can use Forge as well. And the name of my contract, I'm just going to name it DEX. And we're going to start from an empty contract here. Once that is done, we'll just switch into our DEX contract project and we'll open that up in our code editor. So once you have that open in the contracts folder, we're going to go to the contract.so file here and we're going to start creating our DEX contract. So let me just close this. And the first thing we're going to do here is we are going to import the base ERC20 contract from thirdweb. So I'm going to do at thirdweb-dev/contracts/base/ERC20 base.so. And once we have that imported, our contract here, we're going to name this our DEX contract, and it is going to be of ERC20 base. Now I'm just going to remove the constructor function here for now. And in this, we're going to first store an address, which is going to be our token address. So we're going to say token. Then we're going to create our constructor here. And our constructor is going to need to also deploy us our ERC20 token. So, which is why we are taking in our base ERC20 token here. This token is going to be the liquidity pool token, or the token that is provided to a user who adds liquidity to this DEX contract. So when we add liquidity, say I add 1,000 Sean tokens along with whatever amount of Matic I want to match it, what I'm going to get in return is 1,000 of this DEX token right over here. So what we're going to need here is to also call our base ERC20, and we're going to need to deploy our token through that as well. So for our base ERC20, we're going to need the default admin address. So we'll say default admin. We'll also need the name of our token or our liquidity pool token, and then we'll need the symbol of what that token is going to be. So for our constructor, what we're going to provide it is an address. This address here is going to be the token address that we are allowing for our DEX. We're going to submit an address, which is going to be the default admin address. And we're going to also take a string of memory, which is going to be the name, and string memory, which is going to be symbol. The default admin name and symbol is what we're going to pass here to generate our ERC20 token, our liquidity pool token. And then finally here, we're going to set the token, which is our variable up here, to the token address that we provide our constructor. So again, this is how we're going to set up our contract. Our constructor is again going to take the token address of the token we want for our DEX. We'll then submit the address, which will be the default admin of the contract. We'll set the name and symbol for our liquidity pool token. So now let's create the functions of our contract here. The first function we're going to create is going to get back the balance of the token that we have within our contract, so we know how much is within the liquidity pool. So we're going to create a function here called get token in contract. This function is going to be a public function. It's only going to be a view function, and it is going to return to us a uint256 returns. For this function, all we're going to do is return, and we're going to take our ERC20 base here, and we're going to provide it with our token, and we're going to get the balance of this address. So address this. So this contract address, we want to know what the balance of the provided token is, and that is what this function here is going to return us. Next, we're going to create a function to add liquidity to this DEX contract here. Now, liquidity is going to be us depositing both the Sean token and a amount of Matic in this case, so the native token. And now the first initial time we add liquidity, I can put in however much Sean tokens and however much Matic I want to into this contract. After that, we're going to have to calculate and provide the correct amounts depending on what the balance is within our contract of both the token and the native token. So we're going to create a function here. We're going to call this one add liquidity. This is going to take a uint256, which is going to be the amount of the token that we're going to add. So we're going to say amount. This is going to be a public function. This is going to be a payable function because, again, we're going to be sending the native token along with this. And it returns a uint256 as well. So we're going to set a few variables here. We'll say uint256. We're going to have our liquidity. Then we're going to have another uint256. This is going to be our balance in ETH, which is going to be this address and getting the balance of this contract. So how much ETH or the native token we have in this contract here. Then we're going to get the uint256 of token reserve. So this is how much of the token we have in this contract. And to get our token reserve, we're going to use the function that we created up top, which is get token in contract. So that's going to give us back the amount of our Sean token in this case that our contract is holding. And then finally, we're going to have our ERC20 base, which is going to be our token. And this is going to be our ERC20 base token right here. So now for the first time, again, when we first initially add liquidity, which we're going to do here in this video, we can put in as much Sean token as we want and as much Matic that we want into this reserve. So if we put if the token reserve equals 0, so this is the first time, or maybe we just need to add more into our reserve here. What we're going to do first is we're going to take our token and then we're going to transfer from. And this is who we're transferring it from, right? So we should be transferring it from our message sender. We should be sending it to this contract address. So we'll say address this. And then the amount is going to be the amount that we are adding to the liquidity pool. So this is, again, how much of the Sean token we're going to transfer here. Then we're going to set the liquidity equal to the balance in ETH. And what we're going to do is mint the liquidity token to the person that is submitting or adding liquidity into our contract. So we're going to mint the msg.sender. We're going to mint them the same amount of tokens that they added into the pool here. So we're going to send them the amount. Now, else, what we're going to do is this is for anyone that wants to add liquidity after the fact of the initial liquidity, or if the token reserve is basically higher than 0. And with this one, we're going to have to calculate an amount here. So we're going to create a ERC20 here. This is going to be our reserved ETH or our native token. And this is going to equal our balance in ETH minus the msg.value. So minus the amount that we are going to be sending within this adding liquidity. We are going to require here that the amount be greater than or equal to the msg.value, so the value being sent, times the token reserved divided by the reserved amount of ETH. If it is not, we can say that the amount of token sent is less than the minimum tokens required. After that, once we verify that they can transfer the amount and the amount is adequate to add some liquidity in, we are going to get our token that they want to transfer. We will do our transfer from. We're sending it from the message sender, from the msg.sender to the address, so this contract address. And the amount is going to be the amount that we said that we're adding within this function. And what we're adding here is the liquidity equals the total supply times the msg.value divided by the reserved amount of ETH. And then finally, we are going to mint the msg.sender, the amount of what liquidity. So depending on the amount of the liquidity, that is going to be the amount of tokens that the user or the sender gets sent when adding to the liquidity pool. If it's the initial amount, they get calculated, or they don't get anything calculated. It's just the initial amount that they deposited. If they are not the initial person to add into this liquidity pool, we will calculate the value here, and then that is the amount of tokens that they get sent. And then finally, we are going to return the liquidity here. So that is our function for adding liquidity in our DEX contract. Next, we're going to create the function to remove liquidity. So this is if you want to essentially take your liquidity tokens, burn it, and then receive back the Sean token and the native token from the contract. So we're going to create a function here called remove liquidity, which is going to take a ERC20. We'll call that our amount that we want to remove. This is going to be a public function which returns a ERC20. And in here, we're going to first require that the amount is greater than 0. If not, we shouldn't be able to remove anything like 0 amount of liquidity. We'll just say you can't run that or execute that function here. Then we're also going to store our uint 256 for our reserved ETH amount. So we'll say reserved ETH, which is going to equal this address, this contract address dot balance. Then we're going to get our uint 256 here for our total supply. And we're going to get the total supply here. And then we're going to create a uint 256 for the amount of ETH. So we'll say ETH amount. That is going to equal the reserved ETH multiplied by the amount divided by the total supply. We'll also get the uint 256 for the token amount. This one's going to equal, we're going to first get our tokens in contract. We're going to multiply that by the amount. And then we're going to divide that by the total supply, which is the total supply here. This does not need the underscore here. Once that's done, we're going to burn the amount of the liquidity tokens that the user is basically exchanging back to us. So we're going to burn, and we're going to burn it from the message sender. And the amount we're going to burn is the amount that they are submitting. Then we're going to say payable. And what we're going to pay them back or send back in the native token, we're going to send the native token along with the Sean token back to them. So payable, we're sending this to the msg.sender. And what we're going to do is transfer them to the msg.sender, is transfer the ETH amount. And then we're also going to do that for the token. So we're going to take our ERC20 base of our token, and what we're going to do is transfer to the msg.sender the token amount that we calculated. And finally, we're going to return our ETH amount and token amount here. Oh, and then here we have different arguments in return statement. We're returning 2 uint 256s. There we go. Next, we're going to create a function to get the amount of tokens. So this is going to get and calculate the amount of tokens that you'll receive when you swap. So we will function, we'll call this a get amount of tokens. We are going to need to get the uint 256 of our input amount. We'll need the uint 256 of our input reserve, and then our output reserve. And this is going to be a public function. And this is going to be a pure function that returns a uint 256. So for this function here, we're going to require that the input reserve is greater than 0 and that our output reserve is greater than 0. Then if you want to calculate a fee or anything, you can calculate your fees in here if you want to take 1%, 2%, 3% of swaps or anything. You can calculate that in here. We're not going to do any of that here. We're just going to take whatever the input amount is what they're going to be able to swap for. So we're going to calculate our uint 256 for our numerator. And we are going to take our input amount and times that by our output reserve. Then we're going to take our uint 256 for our denominator, and that is going to be our denominator. And this is going to equal our input reserve multiplied by 100 plus our input amount. And then unchecked here, we are going to return our numerator and divided by our denominator here. And then the last two functions are going to be the functions we're going to create to swap our ETH to our token and vice versa, our token to our ETH or our native token. So we're going to create a function here. We'll call this swap to ETH. And what this function is going to be is a public function that is a payable function. And we're going to set a uint 256 for our reserved token, which we are going to get the tokens in contract. Then we're going to get another uint 256 for tokens bought, which we are going to get amount of tokens, and we are going to provide this with our msg.value, the input reserve, which is going to be this address. So this contract address is balance, and then the output reserve, which is going to be our reserve token. And make sure I spell uint256 correct here. And then all we're going to do is take our token and transfer from the sender the number of bought tokens. So we're going to transfer them the tokens that they are asking for. So when we hit transfer, we're going to calculate the amount of tokens. So they're going to put in the amount of ETH. We're going to calculate the amount of tokens. So for this function here, again, we're swapping to ETH. So we're going to take the token reserved amount. We are going to then get the amount of tokens that we are going to transfer to the user, which we are going to use the function here that we are going to calculate that amount. So we're providing it again with the value of how much Matic or the native token that they want. And we're going to compare it to the balance and the reserved tokens within our contract. We're going to then send that token and that amount to their wallet. And then finally, we're going to do the swap back to ETH. This is going to take the number of tokens sold. So uint256 of the token sold. This is going to be a public function. And this function, we're first going to create a uint256 of the reserved tokens again, which we are going to get the tokens in contract. We'll then get a uint256 for ETH bot. And this is going to be how much ETH or the native token are we going to send back to the user. So we're going to get the amount of tokens again. The inputs here are going to be the value. So the amount that we are sending, the amount of ETH that we're going to be getting, the address, this, and then the balance of this address, and then finally the reserved tokens. And what we'll do here is we will take the tokens dot transfer from. So we're transferring this from the msg.sender. We are transferring it to this address. And the amount is going to be the amount of tokens sold. And then finally, we are going to create a payable and send back the amount of native tokens to the msg.sender. And we are going to transfer the amount of ETH that was bought or that we need to transfer back to them. And then we are missing an error here. Oh, semicolon there. There we go. And then tokens sold. Did I spell this wrong? Probably did. There we go. Token sold. And msg.value. Oh, this shouldn't be the value because we're not sending ETH. We are sending the amount of tokens sold. So this should be the amount of tokens sold as well. And that does it for our contract. Again, we created a DEX, simple DEX contract here. We created a few functions to add and remove liquidity. We created a function to calculate the amount of tokens that a user should receive. And then we created some functions to swap our tokens to ETH and then vice versa to swap. This should be swap ETH to token. And then we have the option to swap our token to ETH. So once our contract is finished here, we're going to deploy this and we're going to use npx thirdweb deploy. And we're going to deploy our contract here. You should get a browser window that opens up to deploy your DEX contract. Now we just need to fill out these contract parameters for our constructor here. So this is going to be the token address of our token that we're going to allow to use our DEX. So we're going to come back here, get our Sean token here or whatever token you deployed, copy the contract address, come back here, paste that in. Then we need to provide it the name of our liquidity pool token. So we're just going to call this a DEX LP token and we'll give it a symbol of DEX LP. And then you can select the network and chain. You're going to want to make sure that this is on the same network and chain that you deployed your ERC20 token that you're going to be using. Then we'll hit deploy now. We'll confirm that transaction here. Again, we'll assign the signature request to add it to our dashboard. And then there you go. We have our DEX contract deployed. Now with this DEX contract, we're going to have to initially add our liquidity into it and approve that this DEX can transfer some tokens and everything for us. So we're going to copy this contract address of our DEX here. We're going to come back to our ERC20 contract here. We're going to go to the Explorer section here, and we're going to approve that the DEX can transfer these tokens on our behalf. So the spender is going to be our DEX. The value, we have 1 million tokens here. So I'm just going to open up a way converter here. I'm going to put in the 1 million here. Take that way value and plug that into here. And I'm going to execute this. And yep, we'll say we're going to give them a spending cap of 1 million tokens. Approve. Cool. Once that's done, we're going to come back into our DEX contract here. I'm going to come to the Explorer section here, and we are going to add liquidity, or the initial liquidity, into this DEX here. So the amount that we're going to do here is going to be the amount of the Sean token, or the ERC20 token, that I want to deposit. So let's just say I want to do 500,000. So we'll just say 500,000 here. I'm going to take that way value, come into our DEX here, paste that. And then I'm going to put in the amount of the native token. So this is going to be the value of whatever native currency of whatever network or chain you're on. In this case, I'm using Matic on the Mumbai chain, and I have 4 Matic here. So I'm just going to put 0.5 of this token here. For this native token, you can put in your native currency amount with the decimal point and everything. You don't need to convert it. We'll do the thirdweb's dashboard does the converting for this value automatically. So we'll execute that. We'll hit confirm. And there you go. So now if I come back to my token contract and I come back to my tokens here, you'll see that the supply is still 1 million. My wallet now only holds the 500,000 because the remaining 500,000 is within our DEX contract. So we have added initial liquidity to our DEX. Now let's actually build an application or Web3 app that allows a user to exchange those values. So I'm going to come back to my terminal. I'm going to clear this out, and we're going to run npx thirdweb create app this time, and we're going to create ourselves a DEX app. So I'm going to say DEX swap app. We're going to use Next.js and TypeScript for this tutorial. And once that's done, let's change into our DEX swap app here and open up our code editor, right? And then before we start building out our app, we'll have to set up our thirdweb provider here. So in the pages folder and in the _app.tsx file, we have our thirdweb provider here. The first thing we have is our client ID, which is your thirdweb API key. So if you come on over to thirdweb, you go to the settings here, you'll have your API keys, and you can create a new API key. We'll drop a link down in the description below on a tutorial video and some documentation more about API keys if you want to learn more about it. But I'm just going to copy my client ID. I'm going to come over to my files and go to this .env file and paste in my client ID there. I'm also going to rename this file here to get rid of example and leave it just as .env. Come back to the _app.tsx file. And then the second thing we're going to have to set up is our active chain. So this active chain here by default is Ethereum. I'm going to switch it over to Mumbai because that's the blockchain that I deployed my contracts to. And then with that, you have everything set. Now I am going to have some styling here that I'm going to add into this home.module.css file. This is just so that our DEX looks nice and everything as we go through it, and we don't need to spend so much time on the styling here. But if you do want to get the same styling and follow along, we'll add a link to the repo down in the description below. So next here, I'm going to open up the index.tsx file within the pages folder, and we're going to build out our DEX app here. So I'm going to delete everything within this div tag that has the class name of container. So all of this here, I'm going to just select it and remove it. This is just the boilerplate code that you get from thirdweb when you create a new project. And in here, we're going to create a few variables and get a few things that we're going to need in order to start creating out our DEX application. So the first things we're going to need are going to be our contract addresses. So we have our token contract, and then we're also going to have our DEX contract. So we're going to grab those two contract addresses. So let's come back here. Let's get our DEX contract here. Paste that in. We'll also come and get our token contract. Copy that. Paste that in right there. Next, we're going to get an instance of our SDK, which we are going to need. So we're going to get our SDK, and we're going to use the use SDK hook from thirdweb. We're also going to need to know the wallet address of the connected wallet, so we know who the sender of the message and everything is. So we're going to create a variable called address, and we're going to use the use address hook from thirdweb. And then we're going to get the instances of our contracts here. So we can get our first contract, which is going to be our token contract. And we're going to use the use contract hook and provide it our token contract address. We'll do the same thing for our DEX contract. And then we're going to get the token symbols and balance. So we can get the token symbol, which is going to be the token of our Sean token here. So whatever token you're doing, we can get the token symbol and that metadata so that we can display it within our DEX. So we're going to get our data. We'll rename this to be symbol. And this is going to equal, we're going to use the use contract read hook. And what we're going to get this from is our token contract. And we are going to get, provided the symbol function is what we're going to need. So we'll get back that symbol. And then we're going to get the token balance. And we can get the token balance of the connected wallet for that token. So we're going to use the use token balance, provide it with our token contract and the address of the connected wallet. And that's how we can get the token balance for that connected wallet. We're also going to need to do that with the native balance. So in order to get the native balance, so in this case, the user's wallet's balance for Matic, we're going to get the native balance here. And we can use the use balance hook from thirdweb, and that's going to get us the balance of whatever the native token is. And then we're going to also need to get the contracts token balance. And this is going to use the use token balance of our token contract, but we're going to see how the DEX contract here, and we actually need to get the contract address. So we're going to provide it with the token balance. We're checking the tokens, how much of the tokens does the actual DEX contract have left, or how much is it still holding from the amount of liquidity we added in. Next, we're going to create some state variables that we're going to need for our application here. First one is going to be our contract balance. And we'll say set contract balance. This is going to be a string, and we're going to make this default here 0. We're going to import this from React. We're also going to get the contract balance for our native token. So native token, or say native value. We'll set the native value. We'll make that a string as well. Set it to 0. We'll do the same thing for token value. Set that to 0. We'll get the form. So this is going to be whether a user is swapping native or they're swapping the native token to the Sean token, or if they're swapping from the Sean token to the native token. This is going to be a string, and we're going to set the default to the native token. And then finally, we're going to just create a state for is loading, and we'll set that to false. Next, we're going to get some of the functions here from our DEX contract. So we're going to get the mutate async. We're going to call this function the swap native token function. And we're going to use the use contract write hook. And we are getting this from our DEX contract. And what this function is going to be is the swap ETH to token function. We're going to do this the same thing for our other functions as well. So we're going to mutate async. We're going to call this one swap token native, use contract write, DEX, and it's going to be swap token to ETH. And then finally, we're going to get the approve token spending, and we're going to use the use contract write. This is going to be on our token contract, and we're going to call the approve function. And this is to, again, approve that we are going to allow the DEX to swap out these tokens and everything for us. So the next thing we need to do is create a few functions that are going to allow us to swap these tokens. So the first one is going to be the amount. We need to be able to get the amount that a user is going to receive when they swap one token to another. So if they're swapping the native token to get tokens, we need to calculate based on how much of the native token they want to swap out, how much of the Sean token are they going to get. So we're going to get, we'll say data, and we'll say amount to get, and we're going to use the use contract read hook here. And we're going to read this from our DEX contract. And we are going to read the get amount of tokens function that we created in our contract. And depending on if we're swapping from native token to the token of our choice, or from the token of our choice to our native token, depending on what our current form is, and if it is equal to our native token, meaning we're swapping native to the Sean token, what we're going to provide it with are going to be the native value. So we'll say we'll convert this two-way using the two-way here. And we're going to convert the native value as a string. And we're also going to provide it with the contract balance. So we'll say two-way so that we can get the contract balance. And then we're going to say the contract token balance. And then this needs to be the value. Or if we're swapping from token to native value, we're going to say two-way. And we will be providing it with the token value as a string, the contract token balance value, and then the two-way, the contract balance. So depending on which way we're swapping, we'll have to provide it with the different information here to calculate the amount of tokens that they will receive. Next, we're going to create a function to fetch the contract balance. And what we're going to do here is run a try catch. And in the catch, we're just going to console error the error. But for the try here, we're going to store the balance here in a balance variable. And we're going to await the SDK.getBalance. We're going to get the balance of the DEX contract. We'll also set the contract balance to balance.displayValue. Or we'll just pass it as zero string here. And then the final function we need to create is the actual executing of the swap function. So we're going to say execute swap. This is going to be a async function here. And over here, we're first going to set is loading to true. We'll run a try catch here. Again, the catch will just console error the error. We'll also just put in a little alert here saying an error occurred. And then for the try here, we're going to say if the current form is equal to native. So if we're going native to token, we're going to await the swap native token. And we're going to provide it with some overrides. And the overrides is going to be the value, the payable value that we're going to be sending, which is going to be the native value as a string. And we'll convert that to a wave value here, because again, that's what we need to provide to the contract. And then once we have done that swap, we can alert here saying that the swap was successful, or else what we're going to do is if we're swapping the other way around, we're going to await first that we have approved the token spending. And we need to provide it with our arguments here. And we are proving that the DEX contract can move these tokens for us. So we're going to say two-way, And then we're going to give it the token value. And then once we have approved that the DEX can move our tokens here, we're going to await the swap token to a native function. And that one, we're going to give it the arguments here of two-way and give it our token value. And then finally here, we're going to alert and say that the swap was executed successfully. And then finally, after our catch here, we'll say finally, we'll set is loading to false. And that does it for our swap function. So again, depending which way we're swapping the tokens, if we're doing native token to regular token, we can just call the swap. If we're doing token to native token, we are going to have to, and I spelled this wrong, approve token spending. Spell that right. There we go. We're going to have to first set approval that the DEX contract can transfer our tokens for us, and then we can call the swap token to a native token here. And then finally, we're going to create some use effects here to fetch the contract balance and update it. So we'll say use effect. This is going to be one to fetch our contract balance, and then we'll set the interval to every 10 seconds. So every 10 seconds, it'll just fetch the contract balance for us. And then we'll use the use effect again here, this time based on the amount to get. And this is going to calculate the amount of the either native token or token that the user is going to get based on their swap. So we'll say if no amount to get, we'll just return out of here. But if there is the current form, so if the current form is equal to native, then we are going to set the token value, and we're going to get the token value, but we'll have to convert it. So we'll say to Ether here, and then we're going to get the amount to get. Else, we'll set the native value to the Ether of the amount to get. So depending again which way we're swapping our functions and everything, our app. And the first thing I'm going to do here for our app is just create a simple nav bar. I'm going to open up my file directory here. I'm going to create a new folder. I'm going to call this components. And in that components, I'm going to create a new file called navbar.tsx. And this navbar here, I'm just going to create a very simple navbar, just a div here that has a display of flex in a row. We're going to space the items with space in between, and we're just going to name it our DEX tester, and we're going to add a connect wallet UI component, and this is going to allow a user to connect to our application with whatever wallet they're looking to connect with. And then I'm going to just add this into the underscore app.tsx file above my components here. So I'm just going to add navbar. We'll save that, and then if I actually run this here, so run the yarn dev, we'll open this up on 3001 here. I should have my nav bar up here in the top. There we go. We have our wallet connected. You can see here I can switch accounts and everything. So we can switch over to, let's say, this account here. There we go. We are not connected with that. So if we take a look back at our demo one here, next thing we're going to do is we're going to create a component for this input here. So the input that's going to show us, we can put in whatever values. It's going to show us what token it is, what our current balance of that token is, and then we can, set the max amount or whatever it is here. And then we'll create this little swap button here where we can swap between the two depending on which way we want to swap their tokens. So in here, I'm going to create a new component. So in my file directory, create a new component. We're going to call this the swap input.tsx. And for our swap input here, I'm first going to create a type of props. And what we're going to provide this component here is one, the type, which is going to either be native or token. So again, depending which input this is going to be for, we're going to also get the token symbol. We'll make this optional here. This is going to be a string. We'll get the token balance. That will be optional as well, because if it's 0, we're just going to put 0 in. And then we're going to get the current, which is going to be the string. So depending which type it is currently on, native or token, then we're going to create a set value here. And we'll set that value to string to void. And then we'll set the max here, which will be a string, and then a value, which will be a string as well. So we'll export our default function here for our swap input. We'll give it our type token symbol, our token balance, our set value, all of our props here. And then finally in here, we're going to say return, and we'll provide it a div. So I'm just going to create one function here, and it is just a truncate function that is going to shorten our values here just to 4 decimal places. And then we're going to build out our input. So within our div here, and I'm going to give this div a class name here of styles. Let me import styles here. So I'll say import styles from should be home. So styles, we'll say styles dot, this is going to be our swap input container. And in this input container here, we're going to create our input field. This input field is going to be a number, right? Because we're putting in the value of whatever we're swapping. We'll set the placeholder here to just 0.0. We'll set the value to value. We'll set the on change. We'll set the value to whatever the target value is. This will be disabled if the current value is not equal to the type. So depending on what it is, we shouldn't be able to, we're only going to allow you to enter a value in the top input, not the bottom input. And finally here, we're going to give it a class name, and we're going to say styles dot swap input. And then below that input, we're going to create a div here. We're going to give this div some styling here. We'll just add in just a few styling here. We'll add position, which is going to be relative, or actually, sorry, this position is going to be absolute. We're just going to move it over a little bit. So absolute. Top we'll say is 10 pixels. And then the right, we'll say 10 pixels as well. So this is going to be us positioning the information of the input on the right, like what token is it, and then the token balance. So we'll first display, we'll say P, the token symbol. We'll add some styling for that. Next, under that, we're going to add the token balance. So the balance of whatever the token is. So we'll say balance. And we're going to display a truncated version of the token balance as a string. We'll add some styling onto that. And then depending if the current form equals the type that we're swapping, again, only the top input field is going to have the ability to change the value. And we'll also add a max button as well, which will just change it to the max amount of the equal to the balance of how much of that token they hold. So if the current type equals type, we'll show a max button. So a button here that says max, and that button is going to have an on click here that is going to set the value to max as a string, or 0, because if you have a 0 balance, it's just going to change it to 0. And then we're going to set the class name here to styles.max button. And that is going to be our input field here. So we're going to come back to our index.tsx here, and we're going to start building out our application and our DEX. So I'm going to create a div in here. This div, I'm going to give some styling, just some background color and everything here. Then I'm going to create another div. This is going to be the card that our DEX kind of lives in. And I'm going to set the, let me create the current form from current form. So depending on what our current form is, we're going to set the native, and then we'll be able to toggle the direction of our inputs. So we'll set it, the flex direction as column. If they swap it, we'll just reverse the column and put the other token up top. So the first thing we need to do is add our input. So we'll add our swap input here, and our swap input, we're going to have to provide it with our current, which is going to be our current form as a string here. We'll provide it with our type. So we'll set the default as native. We'll set the max here to the native balance dot display value. We'll set the value here to the native value as a string, or sorry, the value will be set as the native value as a string. The set value will be set as the set native value. The token symbol, in this case, we know we're using Matic, so I'm just going to set the default to the Matic here. And then token balance is going to be the native balance as the display value. Then we'll do our other swap. So we'll do swap input here. This one is going to be for our token. So current is going to be our current form as a string. The type will be token. The max is going to be the token balance dot display value. The value is going to be the token value. The set value will be set token value. The token symbol will be our symbol that we got. And then our token balance is going to be our token balance dot display value. Now, in between that swap, we're going to have a button that allows you to toggle and switch the two. So we're going to add a button here, which is going to have like a little down arrow. So we'll just copy the symbol here. And then we're going to say on click. What this is going to do is swap and set our current form to swap the places of the input. So what we can say here is going to be if our current form is equal to native, then we're going to set the current form to token, or else vice versa, we'll set the current form back to native. And if we save that and take a look at our app, you can see right over here that we have this input here. We have our balance, which is showing our Matic. We have our token balance, which we don't have our token balance for just yet. And then, let me add the styling to this button here. We're going to give it a styling of toggle button here. And there you go. You can see we can toggle now and switch between the two. And our token balance isn't showing. Let's take a look at that. Token symbol here should be symbol as a string and then balance there. So if we come back, there we go. We can see our Sean token now. Our token symbol is now showing and we can toggle between the two. So I don't own any Sean tokens. I do have 0.5 Matic in this account. So if I wanted to swap 0.1 here, you can see that in return, I would get 998 Sean tokens. If I say 1.5, I will get 1,495 Sean tokens. And if I point 0.05, you can see that calculates to 499 Sean tokens. So we can see our swap is working. Now we just need to create a button here that is going to actually execute that swap for us. So we're going to come back to our code editor here. And again, we only want that swap button to show if someone has a connected wallet, because if they don't have a wallet, then they shouldn't be able to swap those tokens. So we're going to make sure that they have a wallet address connected. And if they don't have a wallet address connected, we'll just say connect a wallet to exchange. And then if they do have a wallet connected, then we'll just create a div here. We'll just give it a quick styling of text align center. And within this div, we're going to create a button. And this button is going to, depending on our loading state. So if we are loading here, it's going to say loading. If not, it'll say swap. And then for our button, we're going to give it a on click of executing our swap. It will be disabled if the swap is loading. So if it's executing our swap, we shouldn't be able to click the button again. And then we're going to give it the, sorry, this should be disabled. And this should be, what is this? Boolean is not accepted to Boolean or undefined. So it adds Boolean here. And then our class name will be the swap button styling. So now come back to our app. We now have this swap button here. So if I wanted to swap 0.05 Matic, you see in return, I would get 499.5 all of this Sean tokens. So I can hit the execute swap button here. We'll see that it is loading. We'll get a transaction that comes up. You can see here, payable. I'm going to swap 0.05 Matic. We're going to confirm that transaction. Our transaction here is loading. We should get a pop-up, the alert saying that our swap has been successful. You can see the values and everything have already changed because, again, it is calculating those different values. Right there, our swap was successful. I'll hit OK. You can see my Matic value went down to 0.47 and I now hold 454.1 Sean tokens. Again, we can swap this around. We'll go max. You can see here though, in return, if I were to swap back, I would get a much lower value of Matic back here. So again, you can see here how we can create our very own simple DEX. And we can create our own little application that will allow a user to swap those tokens back and forth. So there you have it. We built a very simple DEX contract along with a very simple DEX application. And if you want links and to see the GitHub repos for this, again, we'll link those down in the description below. But again, I hope you folks found some value and you liked this video. If you did, give this video a thumbs up, hit that subscribe button, and don't forget to turn on the notification bell so you don't miss out on more tutorial videos just like this. And if you need any help or support, we'll add a link down in the description below where you can open up a support ticket, and our support team will be happy to reach out and answer any of your questions. But again, I hope you folks enjoyed this video, and until next time, see ya.